1 minute. Bino sir.
Yeah, Dinisha, you can start.
A very good evening to one and all gathered here. I'm Denisha Priya from the Electronic and Communication Department, here to host today's workshop on A Simulator World, organized by St. Joseph Robo Club, St. Joseph Institute of Technology. It's my great pleasure to extend a cheerful welcome to you all here. On this beautiful evening, I would like to take this opportunity to extend my first and foremost gratitude to our Honorable Chairman Sir, Dr. B. Babu Manoharan, our Managing Director, Mrs. S. Jessipriya Ma'am, our Director, Mr. B. Stacey Segar Sir, and our beloved Principal, Dr. P. Ravichandran Sir, for giving this opportunity. I would also like to take this opportunity to thank our Head of Department, Dr. C. Nyanakausalya Ma'am, Staff and Students Affairs, and Dr. G. Rohini Ma'am, Lab Affairs, for their endless support. I would also like to welcome the Head of Department and the Lab HODs of the CSE, IT, EEE, Civil, Mechanical Department, and the Department of Science and Humanity. Last but not the least, I would like to welcome the students gathered here for the session. It gives me immense joy to welcome you all to make this event a grand success. It's my pleasure to welcome Ms. Jamuna Najendran, the wonderful speaker of today's session. Now, I would like to share a few words about the speaker. Jamuna Najendran, a woman of Chettinad Vidyashram, is currently pursuing BE in Electronic and Communication Engineering. She is a member of IEEE EMBA Society and the ERC Club. Jamna has won the Mini Project Expo conducted by the St. Joseph Robo Club and has also done other projects like Line Follower, Obstacle Avoider, and Computer Controlled Robot. She has also created a pie game called Space Invader. Jamna has also created a language translator app using Flutter. Before we start the session, I would like to tell few instructions to be followed by the participants. Kindly post your queries and questions in the chat box and they will be discussed with the speaker at the end of the session. The feedback link will be posted at the end of today's program. Now, I invite our speaker of the day, Ms. Jamuna Najendran, to kindly start the session.
Yes, Jamuna.
I muted myself by accident. Sorry. Okay, so I hope the presentation is visible. Can you hear me?
Yes, it is audible and visible.
Okay, ma'am. Okay. So, good evening, everybody. Thank you, Danisha, for the introduction. Okay. So the project we're gonna do today is the password protected door lock. Okay. So I'll tell you guys the basic gist of the project. So the basic gist of the project is that we're gonna have an LCD display. Okay. So in that LCD display, you'll be asked to enter the password. Okay. So you'll enter the password through a keypad. Okay, so whatever you enter in that keypad will get visible on the LCD screen. Okay, so it will check whether the password you entered on the LCD screen is the same as the actual password. If they're one and the same, then the servo motor will be connected to the door. Okay, so the servo motor will open. So that means the door is open, right? So we've got the right password and the door is open. But the door will not remain open for a really long time. It will only remain open for a few milliseconds. Okay. So after that, it will close on its own accord. Okay. It will close automatically. Okay. So let's say we enter a password and the password is wrong. You'll get a display text on the LCD saying that the password you've entered is wrong. Okay, so this is the basic gist of the project. Okay, so let me tell you guys again. So what we're gonna do is we're gonna have an LCD display. Okay, so in that LCD display, you'll be asked to enter the password. Okay, so when you enter the password, it will check with the actual password. Okay, so if the both passwords match, then the door will open and the door will remain open for a few moments, then it will close on its own accord. Okay, so if you enter the wrong password, it will just print wrong password. Okay, so that is the basic gist of it. I just wanted to put it out there first. Okay, so let me tell you guys what we're gonna cover today. So first, I'll tell you what is the password protected door lock, which I've already told you guys. I keep going to the next slide, okay. Which I've already told you guys, and then I'll explain you guys the connections using a Tinkercad tool. So I'll show you guys how to open the Tinkercad tool, and then I'll tell you guys the code. Okay, after the connection, we'll go on to the code, and then I'll simulate the code for you guys. Okay. So then I'll tell you what and all possible future projects you could do. There's a lot of projects that you could do. Okay, I'll just tell you a few of them. Okay. So now I'll just tell you guys how to open the Tinkercad. Okay, so let me go to Google. Okay, so I'll just type Tinkercad here. Okay, so Tinkercad, the first thing that comes is Tinkercad. Okay, so if you click this, the first link, I've used it quite often. So I'll click this. Okay, so here it's loading. Okay, so I've already signed in. Okay, but I think you guys would have something here called sign in, login. You can log in using your Gmail account. Okay, so here you have options called 3D projects, circuits, code blocks, lessons. So we're gonna go into circuits, and we're gonna click create new. These are the projects I've already done. So we're gonna click create new circuit. Okay, so it's loading. So before we do the connections, I'll first show you guys how the finished product will look like. Okay, after we do all the connections, I'll show you guys how it will look like. Okay, so this is the finished connections. Okay, so we have a keypad, we have LCD, we have a servo motor, and then we have an Arduino Uno. I'll explain these connections, but let me first simulate it. Okay, I'll click start simulation. It's initializing, and the simulation has started. Yeah, as you can see, and you get a text called protected door, and then loading. Okay, so then it's asking you to enter the password. So I'll enter something random. Okay, I'll enter A, B, C. Okay, I didn't click C. Okay, fine. I'll enter D hash. Okay, so this is just hash. This is just a random combination of characters that I've entered. It's wrong, obviously. So that's why it said it's the wrong password. So now I'll enter my actual password. Okay, I gave my password as 1234. So I'll give that 2, 3, 4. Okay. So and then it says door is open and the servo motor open. Okay. I hope you guys could see that. And then it prints a message called waiting. And then you'll have 8 dots to be precise. You'll have 8 dots. And then it would say time is up and the server will close on its own accord. Okay, I'll give the right password again so that you could see what happened. So 1, 2, 3. Okay, so as soon as I click 4, the servo motor will open. Okay, keep an eye on the servo motor. So 4. Okay. 4. Yeah, the door is open. So it opened. It's gonna remain open until the waiting finishes. Okay, so second dot, third dot, fourth, fifth, sixth, 7, 8, and then time is up, it will close. Okay, so this is what we're gonna do. Okay, so let's move on to the connections. We've already opened a blank page. So I have this blank page. So the first component I need is Arduino. Okay, so this is the first component. I took it out. There we go. I don't want it in this direction. I'm gonna rotate it. Oh, right. So this is the rotate button, and then you have delete. If you want to delete anything, you could just click it, and then you could just click delete. Okay, it will ask you to confirm whether you actually want to delete it, and then you could give OK. And this is to basically do undo stuff. And what is this for? Okay, you don't need that. You don't need this either. And this is basically the wires. Okay, if you want to change the color of the wires, this is what you're gonna do. You have a wide range of colors available, and then you have the type of wire you want to use. We're just going to use a normal wire. Okay, so I'll take out the Arduino again. Okay, right here. I'll rotate it. And then I'll just drag and place this a little higher. Okay, so right. Okay, so I'll take out the next component, which is the keypad. Okay, so the keypad, I'll take it out. I'll keep it here. Okay, so just so that you guys could see the keypad, I'll zoom out a little bit. Okay, so let me tell you guys about this keypad. Okay, so what we have here is a 4x4 keypad, with meaning that it has 4 rows and 4 columns. So this is the first row, second row, third row, fourth row. and first column, second column, third column, fourth column. So indicating that we have 4 row pins and 4 column pins. So this is row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So what we're going to basically do right now is we're going to do the connections, and we're going to connect these row pins and column pins to any of these digital pins. Okay, so we have like so many digital pins from 0 to 13. So you could connect these row or column pins to any of these. Okay, so I'll connect it from 0 to 7. So there's 8 pins. I'll connect it from 0 to 7. Okay, so let's do that. Okay, so let's first use the color of the wire. Okay, I don't want green. I'll do blue. Okay, I'll do blue. I'll keep it here and I'll place it. It's as easy as that, you guys. You just drag it, click it once. Oh, I don't like that. Okay. You just drag it, click it again. Okay, so you just drag it, click it, drag it, click it. Okay, so now I've connected all the row pins, and then I want to do the column pins. Okay, so I'm going to connect the column pins from 4 to 7. Okay, so the first column pin goes to 4, and the next goes to 5, and the next goes to 6, and the last goes. Okay, okay, so the last goes to 7. Okay. Did I do the connections right? Okay, yeah, I did them right. Okay. So now I'm done with the keypad connections. That's it. That's all you have to do. Okay, so you only have the column pins and you just have to connect them to the digital pin. Okay, so the thing is, you could change the digital pin you want to connect to, but in the code you're going to mention to which digital pin you've connected it to. Okay, so you just have to take note of the digital pin you've connected it to, and you have to mention it in the code. Okay, so just remember that. Okay, and then I'll keep it here. Okay, so the next component we're gonna use is, what component should we use? We'll use LCD. Okay, LCD. Okay, so this is the LCD. We're using a 16 by 2 LCD. Okay, 16 by 2 LCD. Okay, I'll drag the whole thing. Okay, I'll keep this down a little, and so that you guys can see the connection, I'll zoom in a little bit. Okay, so these are the analog pins. Then you have the in ground, 2 grounds, because you're going to do a lot of connections. So you need as many grounds as you could have. Okay, so 2 grounds, and then you have a 5 volt, and then you have 3.3 volt. Okay, so let's move on with the connections of the LCD. Okay, so the LCD, the first pin you have is ground. Okay, so I'm going to connect this ground and the Arduino's ground together. Okay, so that's the first thing I'm going to do. And since it's a ground, I'm going to make it as a black wire. Okay, so I'm going to drag this. And there we go. I'm going to place it. Okay, maybe not there. I'll place it in the upper ground. It doesn't make a difference, but I just want to do it. Okay, so, okay, now let me just adjust the wire. There we go. So we connected the 2 grounds. So the next pin we have on the LCD is the VCC, the power supply pin. Okay, so I'm going to connect both of the power supply pins. So the VCC here and the 5 volt one. Okay, so I'm going to change the color of the wire to red. And then I'm going to just connect it. Okay, so there we go. I'll pull this down a little bit so it looks beautiful. Okay, so the next we have is V0. So V0 is called the contrast display pin, but we're not going to use it, so I'll just ground it. Okay, so since I'm grounding it, I'm going to change the color to black. There we go. So let me just do the connections real quick. So RL is basically in charge of this. So let me first tell you this. Okay, so in our display, we're going to enter a password, correct? So we're going to enter a 4-character password. Yeah, so for that, we're going to use 4 data pins. Okay, so the 4 data pins I'm going to use is DD4, DD5, DD6, DD7. So in order to select which pin I want to use first or which pin I want to send the data to and all those stuff, we're going to use register. In order to enable these pins, I'm going to use a pin called enable. Okay, so I'm going to use this. I'm going to use register select. I'm going to use enable, and I'm going to use these 4 data pins. Okay, so this is what I'm going to use. So I'm going to connect all 6 of these to these 6 analog pins. Okay, so let's do that. So let's change the color. I'll change the color to green. Why not? Let's make our circuit colorful. So A0, the first one goes there. The next is read or write. We're not going to read or write anything. Okay, so we'll just ground this thing because we don't need it. We'll just ground it. Whatever we don't need, we'll just ground it. It's as simple as that. Oops, okay. So make sure like you could see like if it's connected or not. So if you get like a black color box and a red color box, that means it's actually in the spot where you want to do the connection. So make sure you see that, and I'll pull this up a little bit so that you could see. Okay, so that's the connection. And then I have to connect the enable. I'll change the color back to green. And then I'll connect the enable to the next available analog pin, which is A1. Okay, so the next up is data pins. So I'm going to use it from DB4. You can use it from here too, but I want to just use it from here. Okay. Okay, so it goes to A3. I'll align it. A4, and last but not least, it goes to A5. Okay. Okay, so next we have the LED pin. So the LED pin has 2, anode and cathode. Okay, I'm going to connect the cathode to the power supply. And then I'm going to connect the, I'm going to connect the anode to the power supply, and then I'm going to connect the cathode to the ground. So let me first connect the cathode. Okay, so I'll change the color to black, and then I'll connect it. Okay, I got the red color thingy. I'll connect it there. And then we have this. This is the last thing left. Okay, so before we connect this to the supply, we have to use the resistor. So why we use the resistor is because we don't want like too much power to move to the LED, because LED is basically a really fragile component. So it could burn out, it could burst, anything could happen. So I'm going to use a resistor so that I could regulate the amount of power supply passing through this LED. Okay. So I'm just going to use a 1 kilo ohm resistor. I think you could use anything. I haven't tried any other resistor, but you could go wild with it. You could try different options and all those stuff. Okay. So since this is going to the power supply, I'm going to make the color to red. So I'm going to make it right here. There we go. Okay. So with that, the LCD connections are over. Okay. So yeah, we're doing with anything, everything. So last component we're going to use is the servo motor. Okay. So let me get the servo motor. So we're going to use a micro servo motor. Okay. So I'll just keep it here. Okay. Right here seems about good. I'll rotate it because I just need a pin. Okay. So now I'll zoom it in. I'll zoom in. Okay. Okay. So the servo motor has 3 pins. Okay, the servo has 3 pins. So the first pin is signal, and then you have power, and then you have ground. So you're gonna connect the power pin to the 5 volt as usual, as per what we did in the LCD2, and then you're gonna connect the ground pin to the ground. But what do we do with the signal pin? You can connect the signal pin with these remaining digital pins. Okay, so I'm gonna connect them to 9. Okay, let's do 9. Okay. So let me first ground this. Let me change the color to black. Let me connect the ground pin. I'll go here and I'll connect it. Okay. Then I'll connect the power supply pin. I'll change the color to red. Let's maintain a color. There we go. So lastly, we have the signal pin, and as I said, I'm going to connect it to 9. I'll change the color to orange. Okay. I should have done yellow. That's fine. Okay, so there we go. Okay, with that we're done with all the connections. It's as simple as that, basic logic. It's really simple actually. So before we start the simulation, just these connections aren't going to work. I have to code everything. So let's move on to the code. So I'll open my Word document. Okay. So, okay, before we do that, we have like 3 different components other than Arduino, right? So we have a keypad, we have a servo motor, we have an LCD display. So all of these components will have a lot of inbuilt functions that we could use. We could make use of. Okay. So in order to use those inbuilt functions, we're gonna have to call their libraries. Okay. So inside these libraries, those functions are all available. Okay. So it's just you just have to include them in your program. So I'm just gonna call them. So these are the 3 libraries. So keypad.h is the library for the keypad, liquidcrystal.h is the library for LCD, and servo.h is the library for servo motor. Okay, so these are the 3 libraries. I want to use these functions, so I'm calling these libraries. Okay, so that's the first 3 lines. Okay, so the next line is basically what I'm doing here is I'm defining a variable called password underscore length, and I'm making this variable's value as 5 permanently throughout the program. Okay, so throughout the program, wherever you see password underscore length, the value of this is 5. Okay, so just remember that wherever you see password underscore length, imagine there's a 5 there. Okay, just imagine it. So that's these lines. Okay, so that's that. So next we have is the initialization. Okay, so the initialization. So servo, my servo, this is basically the servo library. Okay, so this is the servo object. Okay, so I'll just write it here. Okay, object. So this is the object. So in order to use any function available by the servo library, you have to give my servo in front of it. You have to give my servo dot, my servo dot. Like whatever you want to use, you have to give my servo in front of it. Okay, so that's like something you have to do. So the same thing goes for Liquid Crystal. So LCD is the object. Okay, so Liquid Crystal is the library, and LCD is the object, variable, whatever you want to say. So this is the object, and inside this object, I'm giving parameters like A0, A1, A2, A3, A4, A5. So these basically indicate to what pin the LCD is connected to the Arduino. So as I said, right here, so I told you the important pins, RS, enable, and the data pins. So I've connected them to the analog pins, A0, A1, A2, A3, A4, A5. So you have to mention that in your code. Okay, so that's exactly what I've done. Okay, right? I hope you guys are understanding whatever I'm saying. Okay, so next we have in position. So this is basically a variable which is responsible for the position of the servo motor. Okay, so the position, I typed it wrong, that doesn't matter. Okay, leave it. Okay, so this, what happens is, like suppose the cos is 0 now, it means the servo motor is at a 0 degree angle, 0 angle or something. Okay, so if cos is 90 now, it's at a 90 degree angle. So that's what it's used for. You will understand it further when we move into the program. Okay, so next we have is char data password length. So data is basically whatever password you enter. Okay, so the password you enter is data. Okay, so remember how we enter something into the keypad, we enter the password into the keypad and it gets displayed on the LCD. So whatever we enter is data. Okay, so and we want its maximum length to be 5. Well, you can't exactly enter 5 characters. I'll tell you why. Okay, like for example, okay, first see here, master is the actual password, like the real password, the default password I'm setting. So it will basically compare the data I enter and the master password. If it's the same, it will open the door. Okay, so I set this as 1, 2, 3, 4. Okay, so this is a string 1, 2, 3, 4. So since the length is 5, what would happen is you'll have a null character in the end. So the size is 5, but you can only enter 4 characters. So you have 1, 2, 3, 4, and then I have a null character. Okay, so by default, this is a C++ code. So the C++ code will add a null character in the end. The C++ compiler will add a null character in the end. Okay, so that's exactly what will happen to the data you enter too. So you'll only be able to enter 4 characters. After that, you cannot enter. Okay, it wouldn't accept it. Okay, so next I have variables called data count and master count. Okay, so I'm just initializing these as 0. I'll tell you guys what these variables do in like the upcoming pages. Okay. Okay, so next we have a variable called bool door. Okay, so the variable name is door. Okay, it's a boolean function. So boolean function is basically true or false. So I'm initializing the variable's value as false. Okay, so what does this mean is basically that the door is closed. Okay, it means that the door is closed. And yeah, so that's what this variable means. So it's basically you're just initializing that the door is closed. So you're initializing door is equal to false. And then you have a variable called custom key. So this is basically to do anything related to the keypad. You're going to use this variable. And then you have const byte rows, const byte columns. So const byte rows and const byte columns basically indicate how many rows and columns your keypad has. Okay. So in my case, my keypad, let me zoom out. Okay, my keypad has 4 rows and 4 columns. Yes. So that's what I basically said here. I told the compiler that hey, I have a keypad which has 4 rows and 4 columns. So that's what I've done here. Okay. So the next, what I'm gonna do is I'm gonna tell the compiler how I want my keypad to be like internally. So internally, if I press the key, if I press the first key, I want it to return 1, and if I press the second key, I want it to be 2, 3, 8. So the first row is this. This is the second row. This is the third row. This is the fourth row. So this is how I want it to be. Okay, so this is how it's gonna be. So I'm basically initializing a 2-dimensional array which has rows and columns, and I'm initializing the value. I'm setting the value of this is how it's gonna be. Okay, so next up I have byte row pins, call pins. Okay, so this basically signifies how my row pins and column pins are connected to the Arduino. Okay, so let me show you the connection. I'll zoom in. Okay, as I said, next 4 pins are connected to 4 to 7. So that is what I'm saying basically in the book. Okay, so that's what's happening. So this is what that is about. So next I have custom keypad function. So custom keypad function is available inside the keypad library. Okay, so I'm saying keypad. So this is the keypad library, and then I'm having the custom keypad function. Okay, so this function has 4 parameters: make key match, which is basically these. So it basically signifies these. And then I have row pins and call pins. Okay, so row pins are these. So it will take any of these 4 values for row pins, and call pins, it will take any of these 4 values. And then rows and columns basically signifies the number of rows and columns your keypad has. Okay, so as I said, in our case, our keypad is a 4x4 keypad, and it has 4 rows and 4 columns. Yes, I hope you guys understand that. Okay. So next we have void setup. Okay. So whatever we want to execute once. Okay. So let me tell you this. Okay. So whenever you're creating an Arduino program, you have 2 main functions, 2 really important functions. So those functions are void setup and void loop. So void setup is basically if you want anything to be executed once, just once. Okay, so it's only gonna get executed once. But void loop function is if you want something to be executed more than once. So it could be twice, thrice, or like infinite number of times. Okay, so anything that you want to be executed more than once will be given in the void loop. So we'll go on to void loop. We'll see void loop. First, we'll look into void setup. Okay. So inside the void setup function, the first line I have is my servo attached. So as I said, whenever you want to use any function given by the servo library, you have to use its object, and our object is called my servo. So I'm gonna give the object my servo, and this is the function attach. Okay. So what this line basically signifies is how my uh, servo is connected to the Arduino. Okay. So I told you the signal pin. Okay. Let me zoom out. So the signal pin is responsible for the movement of the servo motor. Okay. So the signal pin is connected to the Arduino in the 9th pin. So that is what I've mentioned here. Okay, I've told the compiler that, hey, I've connected it in 9th pin. So that's what I've given here. Okay, so that's what I've done here. So next I have servo close function. So this function basically makes sure that my servo motor is still closed. Okay, so this is a function call. So if we have a function call, then the compiler will obviously go to the function definition. So let's go to the function definition. Okay, so this is the function definition. So our function is called void servo close. Okay, so this function is basically responsible for closing the servo motor. So if the function, like let's say the servo motor is open at a 90-degree angle. Okay, at a 90-degree angle. So now what I wanted to do is I wanted to go back to its resting position, like 0-degree angle. Okay. So what I'm going to do is I'm going to reduce this angle by 10 degree. Okay. I'm going to slowly reduce it, like not slowly, it will go quite quick. But yeah, I'm going to reduce it by 10. So first it will be 90, and then 80, 70, 60, 50, 40, 30, 20, and then 10, and then finally you get 0. Okay, so each and every time it reduces, it's gonna write its position. Okay, so that you could see that it's reducing. Yeah, okay, so that's what this function is all about. This is how your servo motor will basically close. Okay, so if you're gonna have a close function, you're gonna obviously have to have an open function, because your servo motor is not gonna remain closed. It has to open at some point, right? So let's move on to the servo open function. Okay, so this is our function definition for servo open. Okay, so in this function, let's say it's initially closed. Okay, so it's initially closed and I want to open it. So if it's initially closed, what would be its position? It would be 0. So it would be like here, it would be here. Okay, so now I wanted to increase by 10 degree, and then I wanted to finally reach to the 90-degree angle. Okay, so that's what I'm doing here. So each and every time it increases the 10 degree, I'm gonna write its position. Okay, so that's what we're doing here. I hope you guys understand. Servo open is to open the servo motor, and servo close is to close the servo motor. Okay, so let's go back to our void setup loop. Okay, so I hope you guys understood this function call. This is a function call. Okay, so I defined this function, so I'm calling it. So servo close. Okay, so as soon as I call this function, it would go to the servo close function definition. Okay, so the next line is LCD begin 16, 2. So the 16, 2 basically indicates the dimension of the LCD I'm using. I'm using a 16 into 2 LCD, so I'm gonna mention that here. Okay, and basically this line basically tells the LCD to get ready, because you're about to be used. You're about to be used, so get ready. This line basically tells that to the LCD. Okay, so this is to get the LCD started. So LCD begin, that is the use of that function. So next we're gonna print protected door. Okay, so next we're gonna print that line, protected door. So we're gonna use the LCD print function and we're gonna print the protected door line. Okay, so next we have loading. Okay, so this is a function call. Okay, so this function call has a message, like has a parameter called loading. So let's go to this function definition so that you can understand what is actually going down. Okay, so let's go to the function definition. So this is the function definition. So as I said, this is the function definition loading. Okay, so this has a parameter called char message. So the message in our case is called loading. Okay, so loading will be passed to the function definition. So the first line I have the LCD set cursor. So what LCD set cursor does, it indicates the position where I want the message to be printed. Okay, so let me first tell you guys this. Okay, so if you give 0, 0, it will print in the first line. If you give 0, 1, it will print in the next line. So that's how it will print. Okay, so basically that's how it works. So since I gave 0, 1 initially, here the protected door will be on the first line. Okay, after that I'm telling the LCD to go to the next line and print whatever you're gonna print. Okay, so in our case it's gonna print the message. So the message we pass is loading. Okay, so it's gonna print loading. Okay, so after you print loading, what are we gonna do? We're gonna have a for loop and we're gonna print the dots. So remember, you had loading and dot. So that dot is how, this is how you got those dots. Okay, you're gonna make a for loop and you're gonna make this for loop iterate 8 times, so you'll have 8 dots. So since I don't want my dots to immediately disappear, I'm gonna give a delay of 1000. Okay, so that is how this is what the for loop is basically for, to print the dots. So what's gonna basically happen is, first I'm gonna get a message called protected dot, and then the next line I'm gonna get a print called loading, and we're gonna get 8 dots. Okay, so that's what's gonna go down. So that is the loading function for you guys, function definition. Okay, so after that, I don't want these two messages like protected door and loading ... I don't want this to stay on my screen. Okay, so I want it to be gone. So I'm gonna use this function LE here, and I'm gonna remove it. Okay, so that's what the void setup has. So these are the lines that the void setup has, and this is what's gonna happen. So remember, this is only gonna happen once. Okay, so that's why it's here. Okay, so next we have the void loop function. So as I said, anything that's going to execute more than once. Okay, it's going to execute more than once. Okay, so anything that's going to execute more than once is going to happen in the void loop. Okay, so first what we're going to do is we're going to check if the door is open. So if door is equal to 2, that basically signifies that you're going to check if the door is open. So what do you do if, let's just assume the door is open. Okay, what are we going to do if the door is open? So if the door is open, I want to first make sure that my LCD is clean, like my LCD is clear. Okay, so that's what I'm going to first do. I'm going to clear the LCD just in case there's anything on my LCD. I'm going to clear it, and then I'm going to close my server. Okay, I'm going to close it because I don't want this door to remain open forever. I want to close it. So that's what this function basically does. Okay, it's gonna close the servo motor, and then since it's closed, it's gonna print a message saying that the door is closed. Okay, so that's what's happening here, and I want this message to persist on my screen for quite some time. So I'm giving a delay of 3000. Okay, so that's what's happening here. And then since the door is closed, it's not open anymore. So I'm gonna reinitialize the door value to false. Since the door is closed right now, yes. Okay, so I hope you guys understood that. So next, suppose if this if statement is not true. So suppose this if statement wouldn't be true if the door is open. Okay, so suppose the door is closed. So what do we do if the door is closed? We go to else statement. So in the else statement, if the door isn't closed, we're gonna open it. Okay, if the door isn't closed, we're gonna open. So again, this is a function call. Okay, so I'm gonna go to function definition, open function definition, which is at the bottom. Okay, right here. Okay, so this is the open function definition. So the first line we have in this function definition is the set cursor 0, 0. As I said, if you give set cursor 0, 0, it indicates the first line. Okay, so in our LCD, the first line, this first line, it would print the message. Oopsie, okay. Wait, okay. It would print the message and password. Okay, so that's what's gonna happen. Okay, in the first line, it's gonna print enter password. Okay, so once we get this message, what are we supposed to do? We're supposed to enter something inside the keypad. Yes, so that's what we're gonna do. So whatever we enter in our keypad, this get key function will get it and it will assign it to the custom key variable. Okay, so let's say I enter 1. Okay, I enter 1 in the keypad. Okay, so what will happen is the custom key value will now be 1. Okay, so it will go inside this if statement. Okay, we initialized in the top of the very top of the program. We initialized data count as 0. So this is an array basically. So data of 0 is equal to custom key. So what will happen is data first value. So data of 0 will be 1. Okay, since we entered custom key as 1, it would be 1. Okay, so data will be 1. And then I'm gonna go and print in the next line the value of the data. Okay, so in our case it's 1. I'm gonna print 1. Okay, so then I'm gonna give data count plus plus 1 plus plus. So data count will now be 1. Okay, so now again gonna go up. So if I enter any key, custom key will take that value. So say I enter 2. Okay, so suppose I enter 2. So now data of 1 will be 2. Okay, so it will go and print 2 on the CDC. So you have 1, 2. Okay, so similarly, if you enter another value, say I enter 3. So if you enter 3, then the custom key value will now be 3, and data of 2 will be 3, and it will go and print 3 on the LCD screen. So now the value you have on your LCD screen will be 1, 2, 3. Okay, so similarly, then after that, I go and enter 4. Then the LCD screen will finally print 1, 2, 3, 4. Okay, so now that we enter the password and LCD has displayed our password, what do we do next? Okay, we check if the password we've entered is actually correct. Okay, so how do we do that? The first and very foremost thing you have to do is you have to check entered. Okay, so say I enter 5 characters and the password length is actually 4. Okay, so the password length is 5. So, but it has to be 4. Okay, the password length has to be 4. So this would be 5 minus 1, 4. Okay, so data count has to be 4. Only then do we have even a chance of the password being right. Okay, if it's 4, it doesn't necessarily mean the password is definitely right. It just means that there's a chance that the password is right. Okay, so count as 5, and it's supposed to be equal to 4. Then that immediately means that the password is not right. There's no chance that the password is right. So that is the first mistake. That's the first thing to understand. So if this if statement is true, so suppose the data count is 4 and the password length minus 1 is 4, which is equal. So it will go to the next if statement. Okay, so in the next if statement, we have strcmp. Strcmp is taking a string function to compare 2 strings. So the 2 strings we have is the password we're going to enter and the default password. Okay, so what is the default password? The default password is 1234. Okay, so suppose the data I enter is 1234 and the default password. So master is the default password. So suppose this is also 1234. Then my strcmp function, this is used to compare strings, will return 0. Okay, so if this is true, it will return 0. Okay, but in front of this we have a not. So not 0 is 1. Basic Boolean algebra. Okay, I guess it's Boolean algebra. So basic Boolean algebra. So not 0 is 1. Okay. So if whatever expression given inside the statement is true 1, then that means it's true. So it will go inside the if block. So first, what are we gonna do first? We're gonna make sure our LCD is clear. Okay, we don't want anything. We're gonna clear everything. We're gonna have the clean slate. Okay, so we're gonna clear the LCD. And next up, we're gonna open the servo motor because the password we entered is right. Okay, so if the password is right, we need a reward, and we want the door to open. Okay, so we're gonna make the door to open. So that's what this function will do. And then we're gonna print that the door is open. We have to tell them that the door is open. Only then, well, we're just gonna print that. Okay. So we're gonna print the door is open, and then we're gonna initialize door is equal to true. Okay, because the door is open, right? So that means the door is open. So we're gonna initialize that the door is equal to true, and then we're gonna keep the door open for a few milliseconds. Okay, so we're gonna keep it open for 5,000 milliseconds to be exact. Okay, so after we keep it open for quite some time, as soon as the delay gets over, I'm gonna print a message called loading, and we're gonna pass the parameter waiting. So this is actually the loading function we have up there. So this function, okay, so it's the same as the loading text we gave up in the setup function. So here the message you're gonna have is waiting. Okay, so waiting. So the waiting message will get printed. So instead of if you get printed in the second line, click that the second line, and then you're gonna have so that's what's gonna happen here. This function you're gonna just pass waiting, and you're gonna print the waiting message, and then you're gonna get it. So that's what's gonna happen here. Okay, so yeah, so okay, yeah, so we printed waiting, the door is open, then the door below this line, so the door is open will be on the first line, and below this line you'll have waiting and 8 dots. Okay, so as soon as this is done, we're gonna clear the function. Okay, as soon as the 8 dots gets over, we're gonna clear the LTP, and we're gonna print the statement called. We're gonna print the sentence time is up. Okay, so the time is up, and then we're gonna have this light message on the screen. Be precise. And then after that, we're gonna close the server mode. Okay, we're gonna close the door. Okay, since we're closing the door, we have initialized the variable as first. Okay, so this is what's gonna happen. So if the Q password, the password you enter and the actual password is the same, then the door is gonna open. That its block is gonna take place. Okay, it's gonna compile. And if suppose the password you've entered is wrong, if it's wrong, what would happen? You're gonna make sure the LCD screen, the LCD display is clear, it doesn't have anything. And then you're gonna print wrong password because obviously the password you've entered is wrong. And you're gonna make sure the door remains closed. Okay. So after all of this, I'm just gonna give a delay of 1,000 milliseconds so that everything could, take place and everything happens without any like overlap or anything. And then I'm gonna clear the screen. Okay, I'm gonna make a clean slate, and then I'm gonna give a function called clear data. Okay, so let me tell you guys what this function does. Okay, so LCD clear only clears whatever was given through LCD print. Okay, so it will only clear wrong password and all those stuff. So whatever I give using LCD print, it will clear. Okay, but it wouldn't clear the password I've entered through the keypad. So in order to clear that, I created a separate function. Okay, so that function is called clear data, and I have it right here. Okay, so as I said, if you enter the password, your data count is gonna get incremented. So after you've entered your complete password, your data count value will be 3. So it will check if 3 is not equal to 0, which is true. Okay, so then it will go inside and it will have data count of 3 is equal to 0. So the last entry you've given will be made 0. Okay, so then since it's given minus minus, the next when you go to the while loop, your data count value will be 2. So 2 is not equal to 0. It will go inside. So then data of 2 will, so the third entry you've done will be made 0. So similarly, the loop will go on until everything, like the whole data you enter is here. Okay, so this is the program. So this is the complete overview of the program. So now let's go and simulate it. Okay. So I've done the connections here. Let me zoom out, and then I'll go to the code section. I'm not going to use blocks, but using blocks is quite easy. But since I have a code, I'll use the code, and when I click this, it will ask me a verification message. I'll just give continue, and I'll remove whatever is here. And there, I pasted my code. So this is my entire code. Okay. So let me run this for you guys. Start simulation. Okay, so it's initializing. The simulation has started. You can see a timer. You get the protected door message. Then you have loading. You have 8 dots. After that, you'll be asked to enter the password. So I'll enter something random, 5, 8, 9, 6. Wrong password, obviously. So then I'll enter the right password, 1, 2, 3, 4. So the door is open since I entered the right password. So now I'll get a waiting message. I'll get 8 dots, 3, 4, 5, 6, 7, 8. There, time is up, so it closes. Okay, so then it asks you to enter the password again. So this is the basic project we've done. So I hope you guys understood what I told you guys today. So now I'll tell you guys about the possible projects you guys could do. Like the components which we've used for this project is basically an LCD. We've used a servo motor. We've used a keypad and all those stuff. So you have a numerous number of projects that you could do from any of these individual components. Okay, so I've just given you like 3 examples, but you have like thousands and thousands. You have so many projects that you could possibly do. So you could do a soil moisture detector. Like you could, the basic, what this project actually does is, suppose you have a plant at home and you keep forgetting to water it or something. So you could use this soil moisture detector to check how much moisture is available in your soil. So then you have this TV remote control project. So what this project basically does is you have a servo motor, and you could control that servo motor using the TV's remote control. So that's how that works. So then we have Arduino Sunflower. So this project is like, I love it. Okay, I love it. So what this project basically does is, you know how sunflowers move towards the sun? Yeah, so that's what this project basically does. So you have LDR sensors, light detecting resistors, right? So you have LDR sensors, and wherever those LDR sensors sense light, your sunflower will move towards it. I'll show you guys images of these circuits, so just that you could get some idea. So this is a soil moisture detector circuit. So you have an LCD, and then you have an Arduino, and then you have a soil moisture sensor, and then you have a breadboard. Okay, so this is a soil moisture detector. Then you have the TV remote control. So this is, let's say this is your TV remote control, and then you have an IR sensor. This is the LCD display, and then you have a servo motor, and then you have the Arduino. So this is the TV remote control. So this is just to give you guys ideas of how you could proceed with your projects. And I'm just putting it out there that you have so many stuff that you could possibly do, and you're not restricted or anything. So this is the Arduino Sunflower. I find this really cute. So you have the sunflower and you have LDR sensors here. Sorry, LDRs here. So whenever you put a light on them, so the sunflower will move towards it. So that's basically it. So I told you guys 3 projects which you could possibly do if you guys want to. And like there's so many other projects that you guys could do. So it's all up to you guys. You guys could do anything. Okay? Okay. Thank you.